Let's take a look at the periodic table of the elements. First off, we should define what is an element. Elements are any substance made from only one kind of atom. There are 118 elements that we know of that are on the periodic table. 92 of those can be found in nature, ranging from hydrogen out through uranium. The rest are made and studied in labs, but you're not going to find them in nature. They're too unstable. Some common elements that you've probably encountered or interacted with are carbon, which is in its natural form is basically coal, or diamonds. Iron, oxygen, nitrogen, neon, things like that. You've also got some uncommon ones, some things that you'll probably never encounter unless you're a researcher, like Einsteinium or terbium. The periodic table is actually a fantastic reference we have for all these elements. It lists them from the lightest, hydrogen, up in the upper left, down through the heaviest in the lower right. We've got a number of criteria that we have them listed by, and a lot of actually very pertinent and important information in each of the boxes. First off, you've got the element's name. You also have a shorthand reference to it, which is what we use in chemical formulas, so we don't have to write out the elemental name every single time we want to reference it in some sort of a chemical formula or equation. It also includes the atomic number, which is very important. That's really what makes an element itself. It's the number of protons in that atom. Typically, in its normal state, unless it's in some sort of an ionized state, that's also the number of electrons. Sometimes that's the number of neutrons, but that's not always the case. Let's take a look at oxygen, for example. Oxygen has an elemental number of 8, which means oxygen has 8 protons and normally 8 electrons. Normal oxygen will have 8 neutrons, but you might have an isotope which has 7, or an isotope which has 9. These will sometimes have slightly different chemical properties. Some periodic tables also like to include the atomic mass, which is an average of the atomic weights, the atomic masses of every variety of that element and all its isotopes. The periodic table is organized into rows called periods and columns called groups. Every item in a row, going from left to right, is chemically dissimilar from the next item in that row. They don't interact the same way with other elements at all. Columns are not the same. As you move up and down in columns, you're going to find very similar chemical reactions. It's just different per each group from left to right. Hydrogen is kind of its own special case. It fits off not really with any of the other groups or any of the other periods. It's kind of its own thing. Hydrogen is the most common and abundant element in the entire universe. It's what primarily composes stars, and it's what fusion in the stars is made into pretty much all of the other elements. As you go from left to right on the periodic table, from the alkali metals all the way over to the noble gases, you decrease in reactivity. Alkali metals are incredibly reactive. Noble gases, they don't interact at all. You've got a number of different groups on the periodic table. Things like alkali metals, alkaline earth metals, transitions, basic metals, semi-metals, nonmetals, halogens, lanthanides, and actinides. But to simplify it, we can actually cut it down to 3 main groups. There are metals, nonmetals, and semi-metals. Metals are typically conductive, malleable, so if you hit them with a hammer, they're just going to reshape, they're not going to break, and reflective. They will reflect light when it's shown on them. Nonmetals aren't. They're non-reflective, they're non-conductive, they're brittle. You hit them with a hammer, they're going to break. Semi-metals are weird. Sometimes they behave like metals, sometimes they may not behave like metals. Silicon is a prime example of a semi-metal. It's actually what allows us to have modern electronics. In the right circumstances, silicon is very conductive. At other times, it's not very conductive at all. It's shiny and reflective, but it's very brittle. You hit it with a hammer, silicon breaks. All the semi-metals have similarly mixed properties. One of the things that's so important about this periodic table is that as you learn more about elements from a chemical standpoint, you can just look at an element and its position on the table and predict reasonably well how it's going to interact with other elements. in chemical reactions. The periodic table is incredibly easy to search to find elements, whether you're looking by atomic number, by name, or by group, or period. And it'll be an incredibly valuable resource for you.